So yesterday we talked about, I'm only putting this up here for Sam because he's gone and it didn't show up yesterday. So I think Sam did things that were naughty. Yeah. Somebody said to me, extended vacation. Hey, that was me. Yes, I know. Okay, so yesterday we talked about finding missing sides and missing angles using trigonometry. So you start with the pieces that you're missing. Like this one was opposite hypotenuse, therefore we knew we had to use sine, just like the one that we did on warm-up. We ended talking about missing sides and angles. If you're missing an angle, then you have to use sine inverse or tangent inverse. You have to use the little -1 guy on your calculator. And then we talked about the definition of angle of elevation. Okay, this is super important. Not gonna lie, there's a couple first hour people that I wanted to throw them out the window by the end of the hour because on every worksheet question, they're like, well, is this the angle of elevation? And they're drawing their angle like this. And they're like, hey, this is the angle of elevation. No, angle of elevation is horizontal and up. Okay. Then they're like, well, then this down here is an angle of depression because it's on the bottom. Nope. Angle of depression is horizontal and down. Okay, so make sure you remember that. If you need me to tell you again, I'll tell you again, but it's in your notes. We talked about line of sight, which is the diagonal there, and we did one example about Bob and his kite. So let's do a couple other examples. I know. It's a beautiful drawing. Wait till you see the rest of today's drawings. Very excited. Okay, so let's say that you are working out west as a park ranger. Do you know that this is that a tower? Yes, a tower. Thank you. That is a fire watch tower. Very good. Okay, so there is actually a thing out west because there are forest fires that they have rangers who have to watch for fires. And actually one year I was doing this an example like this, and somebody said, my dad used to do that. I was like, oh, that's cool. So it's a real thing. This is the best red I got right now. So you unfortunate little soul are... What? Doesn't look like a snowman. It's a fire. You are on fire watch. That is, you're wearing green there because you are a park ranger, and there are your binoculars. So here's your hat. Okay. You know that your fire tower is 200 feet above the ground. And you see a fire at an angle of depression of 4 degrees. Yep. How far away is the fire from the base of the tower? Now, this is very much stripped down geometry problem because truly they put fire towers on the top of a hill so that you can see farther. So you'd have to actually have like your height above the average ground level, but I'm not getting into that. We're not going to go into how tall is the person. You're 200 feet above the ground. You. It doesn't matter. Why is Braden getting space for no reason? Okay, so I'd like to know, how far away is the fire from the base of your tower? Because what would happen when you're doing this is actually, it would be, you would have a triangulate a position with somebody else. So somebody else in their fire tower would be like, hey, I see smoke at this degree, and this far from my fire tower. And somebody else would say, for my fire tower, it's this many degrees, and at this distance from my fire tower, that lets them pinpoint where the thing is.
So this is used in real life.
Yeah.
So this is 4 degrees. And this is
That's angle of depression.
this would be 2 degrees.
Okay, so angle of depression. This is what I want to caution you on, and don't yell at me right away. Okay, there's a couple of things. Angle of depression is horizontal and down. Okay, angle of depression is horizontal and down. So this is 4 degrees. Okay, now, okay, I want you to listen to me a second. Do I know the opposite, the adjacent, or the hypotenuse? I know the opposite side is how much? 200. Now, I want you to listen to me just 1 second. There are variations in how you can draw this, but please be careful. Okay? You could just talk with me before we do any of the actual trigonometry math. What's this angle measurement here?
90 minus 4, 86.
86. Okay, so what if you are somebody who drew your triangle like this, and you were like, hey, I would like to draw it like this with this diagonal. How many degrees is that?
4.
Also 4. Okay, so that is okay. Just be careful that you realize that you're not doing an angle of depression anymore. It's okay, because they're the same, but be careful, because sometimes it matters. Okay, sometimes it matters. You can go ahead and go. Sign out for me though. Okay, so anyway, just be careful. That's what I have to say. So anyway, whether you use the blue triangle or you use my pencil triangle, you're going to come up with the same math. Sine, cosine, or tangent? I totally forgot to say, how far is the fire from the base of your tower? There you go. So it would be here, or it would be here in your other one. Because those horizontal distances are a rectangle. The horizontal distances are the same. Okay, so tangent is correct. So tangent of 200, no. Tangent of 4 is equal to 200 over x. Okay, we talked about this yesterday. What are you allowed to do here? Swap those things. So x is equal to 200 divided by the tangent of 4.
Hey, Miss Dougie.
Yep.
How many feet are
5,280. So you're looking at about half a mile. Okay, so this should be, if you do this, it's 2860.1 feet.
Wait, I have a question. So for the blue triangle, the
Yep.
bottom right angle, that's not angle of elevation? Because it says
So, okay, so listen, when you're, it's the same measurement, right? It's the same measurement, but it's not called an angle of elevation, because when we talk about angle of elevation and angle of depression, we're talking about somebody looking, right? And it's always from the perspective of horizontal and down. Okay, so if I was doing the same problem and I wanted to call it an angle of elevation, I would give you a story, something like the fact that there's somebody starting a fire on the ground, looking up to see if the ranger is seeing them, and the angle of elevation from the ground to the ranger is 4 degrees. Do you get what I'm saying? It's about where, the perspective of where it's coming from. Do you get what I'm saying?
Yeah.
It's a terminology thing, and because of geometry, they're the same, but you got to just remember that angle of, here's the mistake that people make, okay? people make the mistake and they're like, oh, I'm going to draw this, right? And they're going to be like, I'm just draw my triangle in first. And they're like, oh, this is an angle of depression.
Yeah, that's what I should do at first.
Yes. And that's the danger there. You have to know that angle of elevation, angle of depression are always with horizontal. Okay. That's the mistake that I'm trying to avoid by telling you to draw the horizontal and go down. That's pretty much the reason that we got that going on. Okay. Let's do another example. That's not for you though. Let's say that I had all kinds of fabulous stories from previous years and I can't remember any of them. So let's say you have given up your life as a fire ranger and instead of, you got tired of it, too much smoke inhalation, and you've been promoted to lighthouse keeper. Okay, so also true math. So do you guys know why they have lighthouses? Yeah, keep boats from hitting the shore. No, that's the cliff with some rocks at the base of it. You know? So, here's a boat. Sailboat. Okay. And you guys, if you were to look at marine charts, especially older ones, because we have GPS now, so things are a little bit different. But in the old days, it would give you like the elevation of the light, like how far is the light above sea level. It would give you all kinds of other information, but the elevation of the light above sea level would be what you would use to do some of your navigating and to keep you away from the rocks. So let's see if I can make a lighthouse. I don't have red today, so too bad. This is where we struggle. They end up looking like ends up looking like a sad water tower. Here we go, like this. Whatever. Okay. So there's a lighthouse. There we go. So let's see. We got a person in the boat. The person knows that the lighthouse is 500 feet above sea level. That's very foggy, which I am not drawing the fog in there because it's very foggy. And so they have no idea, that's fog, how close they are to the shore. But how close they are to the rocks, they're trying to get into shore because it's too dangerous to be boating. So they're not going to turn around and go back. That comes because first hour didn't like my story. They're like, just turn around and go back out to sea. Shut up. You're trying to get to shore, but you don't want to hit the rocks. So you know that your angle of elevation to the light is, let's see, 65 degrees. You also know that your boat, based on the shoreline charts, cannot come closer than 200 feet to the shore. Okay. Are you in danger? Okay. There you go. That's what I want to know. Based on the rocks and everything else, your boat cannot come closer than 200 feet to the shore. So I would like to know if you are in danger. Well, such an excellent drawing. Cole's laughing at my drawing.
I wasn't.
You know, Cole's a really good artist.
Not really.
You guys, this is about as good as the artwork gets. That's the truth. I took a drawing class once online. It was a 6-week drawing class, and I'm 6 years into it. That's the truth. Yep.
Nice.
Mm-hmm. I have 4 drawings done.
Do we see
Can
them?
you show us?
Sometime. They're at home.
Instead of cat stories, you should just bring in your
Oh,
drawings.
come on, cat stories are great.
It'll last 3 minutes because there's so many drawings.
Yeah, we never got any cat stories.
That's because you guys were terrible.
Well, can you
Oh,
cat stories?
yeah, maybe get some maturity, then you'll get some crazy cat stories.
I thought we were pretty mature.
You missed
I felt
out.
like we were pretty good. Okay. Besides 6, 7, we were pretty good.
Mm-hmm. I didn't tell you any stories?
No. No.
Oh, that's so sad.
No, because you went to go on your phone and Sam said this generation and their friends, you told them to fight.
Maybe I should tell you a story while Sam's gone.
Yeah.
Just because.
Just because.
Just because Sam's gone. And he makes fun of me all the time. So, there we go.
We got plenty of time to tell them.
Get him back.
Angle of elevation. Is that your top angle or your bottom angle? Bottom angle. Angle of elevation is, it's from the perspective of the boat, which is a good clue. This is the perspective of the boat. The angle of elevation then is horizontal and up. Totally fine if you have your triangle oriented this way. Just remember that this is the angle of elevation down there. Okay, so this is the one that's 65 degrees. You know the opposite side because that's how far the lighthouse is above sea level. If we put, I'm going to destroy my picture. So sad. If we put the triangle on the picture, it looks like this. Right? That's what you're looking at. So this is 500 feet. Okay, so are we looking for the opposite or no, we have the opposite. Are we looking for the hypotenuse or the adjacent? Yep, we're looking for adjacent. So what are we using? Yep. Okay, so tangent of 65 is equal to 500 over x. Okay. Okay, so what do you get for x? X equals what? 233.15 feet. So you're not in danger, but you should probably turn. Right? You're okay. You're not closer than 200 feet, but you're getting close. So be careful. That's really what we're going for.
If you were doing the second triangle you have there, where would the angle go in the top left?
Yep.
Okay. So you pretty much just put it on a horizontal diagonal line.
Horizontal. Correct. Okay. Let me give you one more, and then I will, unless you have lots of questions, I will give you homework time. What I will say to you is the ones that we're doing today, that we're practicing and that are on your homework are honestly below test level. But you got to have a solid foundation in this before we move into the ones that are more difficult, which is what we'll do tomorrow. Just wanted to throw that right out there for you. Okay, so here's your last one. So you have given up, you didn't like lighthouse keeping because it was too boring. So you signed up for the military.
Oh,
And because of your particular set of skills, they decided that you could be a sniper.
no.
So they send you to the Middle East, which is why the buildings are brown. Just in case you wanted to know. And you are chasing bad guys. This is a bad guy. Okay? He's just a regular old bad guy. I don't know. Maybe you're not in the Middle East, but you got brown buildings, so you're in the Middle East. Now listen, when
I didn't say that. I'm listening.
what?
She said bad guy, not brown guy.
I said he's a bad guy. That says bad, you goob. Buildings made out of sandstone, Jack. Don't be an idiot. Obviously.
If Jack was here, you have a job.
Okay, so anyway, when they send out snipers, you know they send them out in teams of 2. You know that?
Yeah.
Because you have a spotter and you have a shooter. Okay, so you, being the shooter, actually I got to put you back a little further. Sorry. Is there a gun? on a tripod. Not very good. And here's you laying on your stomach. Okay, there you are. Looking out your rifle. You can't even see anything. It just looks like lines on there. Okay, here's your spotter. He's standing next to you, but this is a very flat perspective. So there you go. So your spotter is just standing next to you. Your spotter knows that your building that you're on is 120 feet high. And he's got a scope. So you guys, spotters have scopes that are distance finders. So he knows that the line of sight to the bad guy, not the brown guy, to the bad guy is 500. Nope, sorry. I just switched to meters. 1,500 feet. Okay. Part of the spotter's job is to help the sniper calculate angles and do all those things. So I need to know, what angle does the sniper need to use?
You have to count.
You do.
What angle? One on the right or one on the left?
Okay. Your angle matters to your sniper. It doesn't matter to your bad guy. Right? So, if I was going to draw this is why I would recommend drawing it in.
I'm drawing it right now.
Okay. Horizontal, right? When you're drawing your horizontal, hang on. When you're drawing your horizontal, take the horizontal from the perspective of what you're looking at. In this case, it's the perspective of the sniper. The bad guy doesn't care about the angle. You're going to be dead. Yeah, I know. It's okay. That's why you're not the only one, I'm sure. So that's why we need to talk about it. Yep. Because we're talking about the angle that the sniper needs. So that means the horizontal is going to come from his perspective. Okay. And so if then the only other thing, horizontal's here, he's going to be looking down. So that's why I drew my diagonal there. You guys, I tend to draw my triangles in the perspective that it matters to the story problem. It helps.
I have something easier. I don't think it's fine. Wait, what? Oh, was that
1,500.
We have to use inverse tangent for this one.
not tangent? Unless I'm-
Oh, it's not tangent. You're right. It's not tangent.
What is it?
It's
Oh, right. No one's opposite adjacent. Is it?
Okay.
sit over
Hypotenuse.
yeah,
line
mine
of
for
sight
this is for
15.
sure.
Oh, I thought it was.
Maybe not.
Oh, shoot.
Wait, what?
Okay. So this is where we're going to go. We're looking for this angle. Okay. That's your theta because the sniper's got to look down and figure out what angles you need below the horizon and all the drop and all that other business. The building is 120 feet high. So this side, the up down, is 120. Line of sight we talked about yesterday is diagonal. Like if you could shoot laser bolts out of your eyes, that's line of sight. Okay, so you have opposite and you have hypotenuse, which means you're using sine. So the sine of the angle is 120 over 1,500. And then if you're missing sine, so we talked about this yesterday again, if you're missing theta and you need to find an angle, then you have to do sine inverse. So sine inverse of 120 over 1,500. What? What's the degrees? Yep, 4.59 degrees. Okay, that's the angle of depression. So you guys, I want you to think about this a second. want you to think about if we're talking about angle of depression, horizontal and down. If you're looking at something that's close, so if I compare my horizontal, like looking at Cole versus looking at Josiah's feet, something that's close to me has a very steep angle of depression, right? Like the distance, this angle, horizontal, and then down, that's a big drop. Whereas if I was like, hey, I'm looking horizontally and I see Cole, and I'm looking then at Jack's elbow, because that's what's sticking in front of Cole's face, like that's not a big drop, that's a small angle of depression. So the farther away something is, the less you're looking down. So this is a very reasonable angle of depression. That's far away. 1,500 feet is like a third of a mile.
Maybe just use a range method.
What do you think this did? You're not, doesn't help you with the angle.
Yeah, it says it has an angle on it.
Shut up. Okay, so you are going to spend the rest of the time working on your homework assignment.